Hello everyone. On this video we will be looking at how to find the arc length of a parametric curve. Okay, so to do that we actually have to go back to Calc 2 and use the formula for an arc length as our starting point. Okay, so if you remember, to find the length of a curve on the interval from A to B. Remember, our parameter is the x-axis, so we're not using parametric curves just yet. We know to use length equals the integral from A to B of the square root of 1 plus dy dx squared with respect to x. And we know that's from Calc 2. Okay, so that's just a little reminder of where we're starting. Okay, so we're going to transform this formula into a formula we can use for a parametric curve. Okay, so what if we assume that our curve C is a parametric curve? Such that x is equal to f of t and y is equal to g of t on the interval alpha and beta for your parameter of t now, where we know that f prime of t, which we know is our dx dt, is positive. Okay, so starting off here, the integral from a to b, square root of 1 plus dy dx squared with respect to x. Okay, so we know that dy dx for a parametric curve is equal to a to b square root of 1 plus dy dt over dx dt. Should have made that a little bit bigger, but hopefully you get the idea with respect to x. Okay, we're not changing that yet. We're just changing our dy dx. If you remember from the previous videos. Okay, now it's a couple of things that we're going to do. One, we're going to make 1 equal to dx dt squared over dx dt squared. Let me make that a little bit bigger. Let me move this up some. Sorry about that. We have dx dt squared plus, since this is dy dt over dx dt squared, we're just going to break that up. Dx dt squared. Now, the one thing we have to remember is that dx by the chain rule can equal dx dt times dt. Since these two just kind of cancel each other out. So we have our dx dt times dt to replace our dx here. Okay, now another thing you want to remember, and we'll do that on our next step, is that L is equal to the integral from a to b, is that this square root, you can separate that from numerator and denominator. So you have the square root of dx dt squared plus dy dt squared over the square root of dx dt squared. And actually that stays. I don't know why I got ready to cross that out. And you have dx dt times dt. Okay, so this does not cross out here. I kind of jumped steps a little. Now, one thing you want to notice is that the square root of dx dt squared, the square and the square root cancels out, so that's just dx dt. So that means this dx dt and this equals dx dt. They cancel each other out. So you're left with your length, since we're no longer a function of x, we're a function of t now. So we're going from t equals alpha to beta. You don't have to put the t equals, but it helps. The square root of dx dt squared plus dy dt squared with respect to t. Or you want to just make it a little simpler, integral from alpha to beta. You have the square root dx dt, that's just f prime of t, squared plus g prime of t squared with respect to t. So either one of those formulas will give you your arc length of a parametric curve. Okay. Now there are a couple of stipulations you have to remember. One, we're assuming that the curve C does not intersect itself on the interval alpha to beta, except maybe at the endpoints. There we go. Okay, so that's one of the stipulations. The other, we're assuming that f prime and g of prime are both continuous on the interval from a to b. Okay, as long as those two stipulations are met, you can use these formulas. Alright, so if you are still writing, please feel free to press pause. But we're going to go ahead and do a quick example. Alright, so for example, say we want to set up an integral that represents the length of the curve for x equals t squared minus t, y equals t to the fourth. Let me clean up that 4 a little bit. 1, t equals 1 to t equals 4. Then you're going to use your calculator to find the length correct to 4 decimal places. Okay, so for a lot of problems, you will have to do the entire integral manually, but for some, they do have problems where they want you to find the integral using a calculator. So if you have a graphing calculator, it would be in your best interest to figure out how to find the integral using that graphing calculator, just in case you run across a problem like this. Alright. So we know that x is equal to t squared minus t, and y is equal to t to the 4th. Okay, so the first thing we have to do, we have to find dx dt and dy dt. Okay, so dx dt, first derivative with respect to t, is equal to 2t minus 1. And derivative of y with respect to t is equal to 4t cubed. Okay, so we have our dx dt and our dy dt. Alright, so now all we do, we plug those into our formula. Okay, so go ahead and slide that up. So our length is equal to the integral from 1 to 4. Square root of dx dt squared plus dy dt squared with respect to t. Okay, so if we go ahead and plug those in from 1 to 4, we have the square root dx dt squared is 2t minus 1 squared. Okay, so 2t minus 1 squared. Dy dt squared is just 4t to the 3rd power squared. 4t to the 3rd power squared with respect to t. Okay, so that's all we've done so far is just plug it in. Okay, so if we go ahead and FOIL two t minus 1 times 2t minus 1, we'll get 4t squared minus 2t minus 2t is minus 4t plus 1. Okay, so the integral from 1 to 4, and I'll put the largest one first, and 4t to the 3rd squared is 16t to the 6th. 4t to the 3rd squared is 16t to the 6th power. Okay, so I'm just going to move that one out to the front. Since it's plus, you can switch them up. So we have 16t to the 6th plus 4t squared minus 4t plus 1 with respect to t. Or you can rewrite it from 1 to 4 as 16t to the 6th plus 4t squared minus 4t plus 1 to the 1/2 power with respect to t, which may be a little easier to just put into your calculator depending on which one you have. Okay, now if you plug that into your calculator, you will end up with 255.3756 as your value, or the length of your curve to 4 decimal places. Alright, so it's pretty straightforward as long as you know the formula. Just find your dx dt, dy dt, plug it in, and you are good. Alright, hopefully this made sense, and I will see you on the next video.